Okay, guys, so in this video, we're going to talk about the last section of chapter 4, and that is linear regression. So in class, what we talked about correlation and how two different quantitative variables can be correlated using a scatter plot, right? So I can go ahead and graph, right, two variables. So I'm going to choose hours studied and test grade, okay? So I'm going to go ahead and compute. And we saw that indeed there is some sort of correlation between them or some sort of association. We can see a linear trend, right? So now the next step that we want to do is like, is there some sort of model that we can probably use to help us predict our test score given the hours studied? So since we're talking about linear patterns, right? The best way to think about it is, well, is there a line that can fit through all these points, right? Well, in reality, there isn't one unique line because if I chose a line, right, a straight line, I mean, this doesn't go through all the points, but right? So what we want to know is like, well, which line will be the best one that will minimize our errors, right? There's many different lines that I can fit. Now, in statistics, we call it something called the line of best fit, okay? And if I go to stat and go to regression, right, and simple linear, right, so these are the steps, I'm going to go ahead and do the same steps. I'm going to put hours studied as my x, my y variable is going to be test grade, and I compute. I'm going to get all this junk. Let me get rid of this. I'm going to get all this junk, which you'll know what this means, right? You'll know what all this means. And then if I click on this arrow, I will see the scatter plot with the line of best fit, okay? Now, what is this line? Well, this line is what we call the regression line, okay? So the regression line is basically the line of best fit that minimizes the sum of squared errors. So in essence, what we're doing, we're finding this line, and this line minimizes our errors that we're going to make because we know that the line is not going to be precise. If I go back, right, this line doesn't go through all of it, right? There is some error, right? Here is this point, right? This point, right? Oh, I don't think you can see. Yeah, so this point at least, right? This one is right up here, and this one doesn't cross the line. It's right over here, right? So there is going to be some error. So a couple things. In order for me to find a regression line or find this line of best fit, I need to make sure that I have quantitative data. The data looks somewhat linear, right? The linearity condition. I want to make sure that there's hardly any outliers. I don't want that. We know that outliers can be a little bit of a pain and they can mess up all of our statistics. So we want to make sure that we limit them or there's not as many, right? Independence, we haven't talked about this in a bit. So just assume independence from now. We will talk about independence later on in probabilities. So don't worry about that just yet. And definitely don't worry about multicollinearity. That's more multiple regression when we have more variables. And as you can see here, we're only graphing two different things, hours and test grade. Multicollinearity tends to occur when there's a lot of variables and you want to use them in your model, right? So things can be a linear combination of the others. So don't even worry about that. But yeah. Okay, so if you remember, so here's something that you should remember. So y equals mx plus b, right? So remember that m is what we call our slope, and b is what we call our y-intercept, right? Or the y-coordinate on the y-intercept, right? So I'm going to go ahead and call my x's my explanatory variables, and my y's my response variables, okay? So basically what we want to figure out, I know what all of my x's and all of my y's are, right? So if I go back, I know what all of my x's are. Here are all my x's, hours studied, right? Hours studied was my x-axis. And I know all of my y's. This is the test grade. So these are all of my y's. So notice that before in algebra, we would just take 2 points, right? Maybe this point and this point. Use the point slope formula or whatever you want to use, right? And we would find the equation of a line that goes through these 2 points, right? But notice that if I choose any 2 points, I will have different lines, right? So how the heck are they calculating this? Okay, so the way that we calculate the best fit line is through these equations, right? So I put the equations down here. These are the equations that you use. Now, you don't need to use it. You will not be able to find the the why am I having a brain fart right now? The slope and the y-intercept, right? You won't be able to find them by hand because they're really, really difficult to compute. Okay. Instead, what we will be able to do is use StatCrunch. Now, something that might be looking a little bit weird, like where did this come from? Well, B0, right? B0 is still my y-intercept. So statisticians have a weird way of writing y equals mx plus b. They read it like this. Okay. So B0 is my y-intercept. I wrote it right here, right? B1 is my slope, right? That's what my slope is, right? So I need to figure out what these two numbers are because I know what my x's and my y's are, right? So the way that we find them is this, okay? So we're just going to use StatCrunch just to solve them or to find the regression equation, but this is basically what the formulas are, what StatCrunch is doing, right? Okay. Now, what is this? What the heck is this? Y hat. This is what we call Y hat. Now, y hat is the predicted y value. So let me go back. So if you see, let me go ahead and click on this. Okay. So if you see, let's look at, I don't know. Let's say we had this point, right? That is what we had. So this says if I study for 0 hours, right, I technically got studying for 0 hours corresponds with a test grade of 40%. That's basically what this says. Now, this is my x value and this is my y value. This y value is a true value. True value. Because I actually went ahead and sampled and this is what I got. Now, my regression line isn't going to give me this. It's going to give me whatever this point is. This point on the line. The points on the line is what we call my y hats. These are what my predictions. And as you can tell, this gives me, I don't know what this number is, but it's probably 0, okay? So it gives me something completely different, right? So we have two different y values. We have the true value, y. Those are the ones that come from here. These are my true values, y's. And then I have my y hats. My y hats come from the line or the regression line, okay? So that's how we're going to go ahead and differentiate them, okay? So, okay, back to this. All right, now how do we find the error between them? It's something called my residual. My residual, E is equal to Y minus Y hat. Okay, all right, and that's what I get. All right, so now let me go a little bit down. Okay, so something that you have to be able to know is how to interpret it. In case you just forgot what a y-intercept was, basically a y-intercept, I know this says something different, but this is basically what it does. If I have an equation of a line, right, let's say it has something that looked like that, and this went to 3. Let's say that was 3. What my y-intercept is, when x is equal to 0, right, as you can see, x equals 0, what is the y value? In this case, my y value is 3. That's basically what the y-intercept is. Y-intercept tells you where is the graph crossing the y-axis. And in this case, it's crossing it at 3. That's all it's telling you. Okay? Now, the slope is a little bit differently. The slope tells you... it compares basically the y and the x value. So basically, if I had a slope of 2, right? So let's say m equals 2. Let me see. This tells me that for every 1 unit that I'm moving in the x direction, y increases by 2 units. That's basically what it is. And some of you guys may see it as the rise over the run, right? So I'm rising up 2 units and moving over 1 unit. That's basically what it is. So so I put it right here. For every 1 unit increase in whatever x is, right? Your predicted y is increasing or decreasing by whatever the slope is. Okay? That's basically what it is. Okay, and if you want to go ahead and jot down this exact thing, then just go ahead and jot it down in a piece of paper, and you can use this for your exam. Okay, but let's do an example, because a lot of this was just terminology, so just so that you guys don't get confused. Okay, so let me go down. Oh, what did I do? Okay, all right, so here is basically the graph. Okay, now I haven't explained what any of this stuff means. So when you go ahead and graph this, right, and you click on regression, right, you're going to get all this junk. Now, what exactly does all of this mean? Now, you don't really need any of this stuff. Oh, what did I do? You don't really need all of this stuff. This you don't need just yet. Okay? What you do need to know is all of this. This, the dependent variable, is usually what we call my y value, right? That's my because it depends on something. What does it depend on? Well, this depends on the x value, right? My independent variable, the hour study. That's my x value, okay? That's basically what it is. Now, this bottom portion, this third line, is what we call my regression equation. This is what we want. And what this says that the test grade equals 34.6, whatever the number is, plus this times the hour studied. So if I wanted to go ahead and write it as y hat equals b0 plus b1x, basically my y hat in this case is my test grade. So this corresponds with the test grade. This B0 is just 34.6. I'm just going to say it's 34.6. And my slope is going to be 7.349, whatever it is, times hours studied. Hours. Okay, let me go ahead and make this a little bit nicer because I know that. Okay, all right. Exit. 7.349. Let's just say that. Okay. All right. And that's it. That's my regression equation. Y hat is this. B0 is this. So this is my y-intercept. This is my slope. And here are my hours. So if I want to go ahead and predict it, let's say I studied for 4 hours. Well, what will my grade be? Well, in that case, I will just plug in 4 equals in here. 4 here, and then multiply it by 7.349, and then add it to 34.6. That's what I'm gonna do. Okay. Now this sample size, this just tells me how many samples I got. In this case, I have 13 observations, right? It actually tells you what my correlation coefficient is, right? So it tells you what my correlation is. This R squared, we're gonna talk at the end, right? Don't worry about what the heck this is. Don't worry about it. Okay. So yeah, so this is basically the result of the simple linear regression. Okay, so make sure that you really know what all of this means, right? This definitely know what they are, right? Because I'm going to be asking you questions about what is what. So no, the first one is your y value, the second one is your x value, the third row is going to be your regression equation. Make sure that it also includes the hours studied. So don't just put 34.6 plus 7.34. That's wrong. Make sure that you put the entire thing, copy paste this. All of this is your regression equation. That is what I'm looking for. And if you want to go ahead and write it in y hat mode, you can go ahead and write it as y hat equals 34.6 plus 7.349 times x. You can write it like that if you want to also. Okay, so you should be very you should know how to use both ways. You should be able to see this is regression equation, this is also regression equation. Okay, and usually the way that I'm going to go ahead and give it an exam, I'm going to give you the output, and then I'm going to give you the graphs, and then I'm going to give you some questions to do. Okay, so I'm going to stop the video here before it gets even longer, and then we're going to go ahead and do the questions. Okay.